The monument to the Great Fire of London is located near London Bridge, a historic city in the UK. This 61.5-meter tall stone column topped with a fiery red sphere is meant to commemorate the Great Fire of London in 1966. In fact, there was another purpose for constructing this monument. This building is actually a giant dome-shaped telescope. It contains a laboratory inside. The name of the famous architect Sir Christopher Wren is inscribed on a plaque at the base of the column. The monument was originally designed by Robert Hooke. Hooke was known as the Leonardo da Vinci of Britain. He made many achievements in the field of science. When Hooke took on this project, he was working to prove the theory that the Earth orbits the Sun. In the end, he decided to build a monument commemorating the Great Fire of London. At the same time, the building also served as a giant telescope. He planned to use the finest Portland stone to create a stable and solid monument. Portland stone and other building stones were always in short supply. King Charles II issued an order that all matters involving Portland stone must first get approval from Sir Christopher Wren. Someone suggested placing a statue of the king on top of the column. Fortunately, the king refused, because it might make the public think he was responsible for the fire. In the end, Hooke successfully built the monument as originally planned. The entire project took about 6 years, and was completed in 1677. The pillar of the monument is twice the width of the telescope. Therefore, 2 huge lenses needed to be installed. The 2 lenses were 61 meters apart, aligned with each other. He observed the sky through the telescope in the underground laboratory. Unfortunately, fixing 2 huge lenses onto the telescope was extremely difficult. Even worse, the building is close to a busy street. The heavy traffic caused severe vibrations, making it impossible to get accurate measurements. Eventually, Hooke had to abandon the plan to use it as a telescope. However, the monument's value in scientific research did not end because it couldn't function as a giant telescope. In the 17th century, tall buildings were extremely rare. Before the monument was built, Hooke planned to conduct his physics experiments, which required tall buildings. The construction of the monument just provided the conditions for him to verify his experiments and theories. So, in 1678, Hooke's laboratory ultimately enabled a successful physics experiment. It must be said, the persistence of scientists is truly admirable. What do you think? Thanks for watching.
See you next time.
Regarding the ancient astronaut theory, evidence of other intelligent life in the universe can be observed from certain viewpoints on Earth. They believe the Earth has been visited by intelligent beings for thousands of years, and this visitation likely began during the era of the ancient Sumerian kings. On March 23, 1843, while excavating an archaeological site in Khorsabad, Iraq, a group led by French scientist Paul Milbert discovered the grand ruins of the Assyrian palace, which contained numerous Sumerian cuneiform inscriptions. During translation, they found these inscriptions told of the world's oldest civilization and a group of powerful beings called the Anunnaki. The Anunnaki are considered the founders of human civilization. Legend has it they had shining eyes, exuding a radiant, extraordinary, and awe-inspiring presence. Based on 30 years of research on Sumerian cuneiform tablets, in 1976, researcher Zecharia Sitchin published a book titled The 12th Planet. In the book, he proposed that the Anunnaki were actually refugees from another world. According to Sitchin's translation of the tablets, the inscriptions record that these extraterrestrial visitors created humans and shaped them in their image. If you look at what we have done in space programs, you might find this is what an alien civilization was doing a long time ago. If the inscription is true, maybe those Anunnaki still exist somewhere in the universe. If humans venture deep into space, they might encounter the original intelligent life that first developed civilization on Earth. However, we are still studying the contents of the inscription. What do you think? What exactly is the center of the universe? The vast universe is mysterious and intangible, and very likely infinite. It's nearly impossible to fully explore the entire universe. For centuries, the geocentric theory dominated mainstream academic thought. In ancient Rome, it was also called the Ptolemaic system. It's an ancient belief that Earth is the center of everything. In the universe, it is stationary. All the planets, including the Sun, revolve around Earth as the center. At that time, this was a widely accepted explanation. Even the great ancient philosopher Aristotle promoted this view. Later, after centuries of research, it was proven that Earth is a planet in the solar system, orbiting the Sun. Today, if someone proposes the geocentric theory, most people would probably find it laughable. But have you seriously thought that according to cosmological principles, the universe has no center at all? From another perspective, this means every place can be a center. If one insists that the universe has a center, there must first be an observable boundary or some kind of shape. But until now, no boundary of the universe has been found. We can only observe as far as the speed of light allows. So the geocentric idea itself isn't necessarily wrong. If you think this is just wordplay, let's explore further. Generally speaking, we tend to imagine the universe has a center. Many scientists believe the universe began about 13.7 billion years ago, with a Big Bang at a starting point smaller by 100 times than a water molecule. According to modern science, this was the origin of all things in the universe. After the initial explosion, it began expanding outward, forming the universe. So, is this starting point the absolute center of the universe? Not necessarily. Here is a simple example. It's like blowing up a balloon. As the balloon inflates, any point on the balloon surface can be considered the center. There's also another possibility, that outside our universe, there exists a negative universe, and our universe is just one of its subuniverses. There are many such subuniverses, possibly all born from explosions in the negative universe, such as black hole explosions, or other events beyond our understanding. Back to the main question, where exactly is the center of the universe? Here's an idea, just to inspire some thinking. Imagine, if we ignored the decimal point in pi, could we find its center number? Pi is the code of our universe. I remember a movie saying there's an integer between 3 and 4. If we find it, we will find the real code of the universe. Although that's science fiction, it might not be without reason. What exactly is the center of the universe? Use your imagination and join the discussion below. This video ends here. Thank you for watching. Many people may have never seen a large tornado. But if you encounter one, what would you do? Tornadoes can occur worldwide. It is a strong air vortex caused by convection in intensely unstable weather conditions. Tornadoes generally occur most often in spring and summer. Tornadoes can frequently occur in both tropical and temperate regions. They occur frequently in both tropical and temperate zones. Except Antarctica, all other continents experience them. But about 3/4 of the world's tornadoes occur in the United States. Each year, over 1,200 injuries and deaths are reported. On average, tornadoes cause at least 80 deaths annually. However, some people do survive tornadoes. The deadliest tornado in world history occurred in Bangladesh. The 1989 Daltapur tornado caused about 1,300 deaths. The deadliest tornado in the U.S. was in 1925, the Tri-State tornado, which swept through Missouri, Illinois, and Indiana. The tornado killed 695 people, the most extreme tornado had wind speeds exceeding 300 to 400 kilometers per hour. Even if you drive at 150 miles per hour, you can't outrun such a tornado. Compared to many natural disasters, tornadoes are unpredictable. They can last for several days and show no warning before arriving. So there's little time to prepare. In tornado-prone areas, people almost always have storm shelters or basements to shield from strong winds, because usually there's no time to escape. Plus, their movement is very hard to predict. If you suddenly face a tornado and cannot reach safety, the best thing is to lie flat on the ground, trying to avoid debris carried by the tornado. These spinning debris are the greatest danger. They usually cause the most deaths and damage. Lying flat reduces injury from debris. Also, tornadoes rarely lift you off the ground. While not foolproof, it at least reduces the risk. In 2011, a tornado in Joplin, Missouri, killed 161 people. Many were injured. Some injured people got infected with a rare fungus. These fungi were from cuts caused by flying wood debris. Additionally, it's believed tornadoes cause the phenomenon of animals falling with rain. Waterspouts, also known as water tornadoes, or water devils, occur over water. They suck up fish and frogs, throwing them far away. For example, Mexico has experienced rain with fish. Northern California cities have had carp rain. Sadly, no pie rain. Otherwise, you'd get free pies every day. This video ends here. Thank you for watching. Please remember to like and follow. The Super Cameo Candy Detector, also called Super K, is a 15-story high-water tank buried 1,000 meters under a mountain in Japan. It is used to detect and study neutrinos. It has reshaped the standard model of particle physics. Neutrinos are hard to detect because they rarely interact with any matter. Billions of ultralight, neutral neutrinos pass through our bodies every second, traveling near the speed of light. If you keep observing, you might eventually see signs of neutrino interactions. Super K uses 50,000 tons of ultrapure water and 11,000 golden photomultiplier tubes. These convert faint light signals into electric currents. Because of its massive size and high sensitivity, it can detect neutrinos from the sun, as well as neutrinos from the atmosphere, and even from a particle accelerator on the other side. That accelerator fires neutrinos at it from hundreds of kilometers away. Back in 1998, just 2 years after Super K started operating, it observed neutrino oscillations, confirming that neutrinos have mass. This discovery changed the standard model, because it revealed a completely new principle in the microscopic world. Super K has already achieved such remarkable results. So what could a detector 5 times larger in water volume and 4 times larger in photomultiplier tubes accomplish? Scientists believe that as Super K's scale expands even further, it will be able to make even more precise measurements to reveal different neutrino speeds in various states. A difference that might explain why the universe created more matter than antimatter at its birth, instead of equal parts that completely annihilate each other. This means that when time began, 3 of the 4 fundamental forces emerged from a single force, which would be the final missing piece in the grand unification theory puzzle. However, the new Super K is not yet completed, so the final answer is still unknown. Back in 2019, researchers added gadolinium to it, making it more sensitive to antineutrinos. I wonder what the results will be.
So let's wait and see.
That's all for this episode. Please remember to like and share. Thank you for watching.
See you next time.
If humans could shrink to the size of an atom, would it be a marvelous journey? From Gulliver's Travels to Alice's Adventures in Wonderland, And even the idea of Ant-Man shrinking has always fascinated us. Atoms are truly tiny. If you magnify an atom a billion times, it would only be as big as a tennis ball. The first obstacle you'd face is your own weight. If you shrank without reducing your weight, then for a person the size of an ant, the pressure on your body would be 10,000 times greater than normal. It's like having a leg the size of an ant, pushing down with a force equivalent to 70 kilograms with every step. Reducing in size would affect almost every aspect of your being. For example, if you shrink to about 2.5 centimeters tall, the heat radiated by your skin would drop by roughly 5,000 times, and your lung surface area would be 5,000 times smaller. Yet you could still obtain the necessary oxygen, because the method of extracting oxygen from air primarily depends on the surface area of your lungs. When you become smaller, it means there will be sufficient airflow, but you'll need to supply your body with more fuel, since the rate at which you generate heat is proportional to your mass. And the only way to produce more heat is to significantly ramp up your metabolism, which means you must keep eating, because food needs to be digested to generate heat. In order to survive, you'd have to eat an amount of food equal to your body weight every day. That's for the 2.5 centimeter version. But when you shrink to the size of an atom, you'll face even greater dangers. During your shrinking process, you would notice the world gradually growing larger, and then growing darker. An oxygen molecule would loom as large as Mount Everest to you. The biggest issue with shrinking to atomic size is that the atoms in your body cannot be made any smaller. Your body contains more atoms than the number of stars we see in the universe. Our bodies are made of DNA, and DNA is composed of molecules built from atoms. We might be able to remove atoms from the molecules that construct DNA, but eventually we would hit a limit. That's it for this episode. Please remember to like and share. Thank you for watching.
See you next time.
Welcome to this episode of Science Magazine. Between Mars and Jupiter, scientists have discovered a huge asteroid, Psyche. Psyche is located between Mars and Jupiter. Scientists speculate that it may have been a Mars-sized planet billions of years ago. After undergoing intense collisions, it lost its outer rocky layer, leaving only an iron core. Scientists believe that it might be primarily composed of metal. Researchers from NASA and Arizona State University plan to launch an orbital spacecraft to it. SpaceX will use the Falcon Heavy rocket for the transportation mission. The launch is expected to cost about $117 million. NASA hopes that by studying this asteroid, they can find clues to the evolution of terrestrial planets. Visiting asteroids is not new in space exploration. When it comes to asteroids, they are almost all the same, but Psyche is unique, because very few asteroids are made of metal, or largely composed of metal. So this is an entirely new exploration, something humanity has never attempted before. Scientists believe that Psyche might be a protoplanet in its early formation stage, in the early evolution of the solar system. Due to violent collisions, Psyche eventually lost its rocky shell, exposing its core. Earth's core is located beneath the surface, at a depth of about 3,000 kilometers. We cannot study it in depth, but this asteroid remains accessible. Studying it might also help us understand Earth. The Psyche team plans to launch in 2022, and they are ready to share this exciting moment with all of humanity. Thank you for watching.
See you next time.
Astronomers have discovered that the mysterious dark energy driving the accelerating expansion of the universe does not appear to be constant. To resolve this issue, astronomers observed a very special type of supernova called an EA-type supernova. When they explode as supernovae, measuring the brightness of EA-type supernovae can reveal their distance. Astronomers plotted brightness curves for these supernovae in an effort to understand how the scale of the universe has changed over time. The results showed that the expansion of the universe has not slowed down, but rather it is accelerating. Astronomers introduced the concept of dark energy. Dark energy might be a constant force. If it is constant, the universe will continue to expand at an accelerating pace. Galaxies and superclusters will drift apart. But in relatively close regions, this energy can pull them apart, but cannot overcome local gravitational forces. At some point in the future, The Milky Way and Andromeda galaxies will no longer collide, but will gradually drift apart. As dark energy continues to strengthen, the gravitational pull of galaxies will no longer be able to hold galaxy structures together, and stars will be flung out, with stellar systems eventually succumbing to dark energy, which will rip their planets into fragments. Space will become empty as the force of dark energy overcomes the gravitational bonds of stars and planets. Matter will be torn apart into molecules, atoms, and subatomic particles. Even black holes will be fragmented. These fragments will be scattered throughout the ever-expanding universe. The universe continues to expand. And this hypothesis is known as the Big Rip. On January 29, 2019, a group of astronomers announced that they have developed a tool capable of measuring the rate of cosmic expansion. Having measured about 1,600 quasars, the results showed that when matter accumulates in the accretion disk around a black hole, it emits ultraviolet radiation. This radiation strikes the hot gas clouds above and below the disk with great force. These hot clouds enhance their energy and emit X-rays, radiated photons. This means you can determine the distance to a quasar by measuring the energy of these two radiations. Scientists have also discovered quasars from 1.1 billion years after the Big Bang. In the 13.8 billion year history of the universe, dark energy seems to be changing, appears to be increasing. If true, this would suggest the universe's future likely leads to a big rip, rather than the universe's solemn fiery majesty. It's the fiery end of countless worlds to come. It will be a violent ending, where even black holes will be torn to pieces. But perhaps in future times, we will have a better answer. What do you think? Please remember to leave a comment